So today we're going to be covering data structures part 2. Um, last week we did conditionals and the first part of data structures, but as mentioned last week, there are a number of data structures to cover. So today we're going to be covering 2. We'll be covering arrays and dictionaries in Python. One moment. All right, so just a real quick recap of what data structures are. So a data structure is essentially a means for storing and organizing a collection of data values. They're generally composed of primitive data types such as strings, booleans, and numeric data types, but they can include other data structures nested within them. And we're going to see that later today. So each has their own set of methods or a defined action that can be performed on the data structure. Methods are called on a data structure using the dot notation. So you'd have your data structure dot the method that you're trying to call, and then you're going to have parentheses after the method name. If there's no parentheses after, that's called an attribute. We'll talk about attributes later on, but for now, we're just going to talk about methods. So there are many different kinds of data structures, each with their own relative benefits and uses. So we've already covered sets. We'll talk about tuples here and there. They aren't as common as sets. Lists, we'll talk about arrays today and lists next week. Dictionaries we're going to cover today, and then objects we will cover later in the course. And then there are a bunch of different other kinds of data structures out there. You can build your own data structures, or you can use the built-in ones. So far, we've just been covering the built-in data structures. So for arrays, an array is a collection of non-unique values that are all of a specified type and they're mutable. So one of the key differences between an array and a set is that they're ordered. The elements within an array have a defined order. So the order in which you enter the elements in the array is the order in which they will remain. So you can see here, I created this array. It's an array of integers because you have to specify the type. And we'll talk about that in a second here. And then in these square brackets, I put in the numbers that I wanted in my array, and notice that the order that I entered up here matches the order that's output down here. So the order is maintained, and that's key for referencing and retrieving values from that array. And we'll see that in the next slide. So they're non-unique. So again, another distinction from sets. Sets, all the values within them have to be unique, but in an array, that's not necessarily the case. So you can have multiple of the same value in an array, and of course, order will still be maintained. So here I created another array, and the values in it are integer type, and I have 4 1s, 4 2s, 3 3s, 2 4s, 2 5s, and a single 6. And you can see that that's maintained in the output of that array when it's echoed back to me from the Python REPL environment. Just one moment. All right, and then specified type. So whenever you create an array, oops, didn't mean to click. Whenever you create an array, you have to specify the type of the array. In the book, it mentioned, hopefully everyone was able to do the readings this week. In the book, it mentioned all the options for the types that you can specify. I'm not really going to go over it here, only because we aren't going to use arrays all that much. I just want you to know that they exist, and there's a difference between an array and a list. Oftentimes in Python, people will talk about arrays and lists as the same thing. They are very similar. They're not exactly the same. So with an array, you have to specify the type. So when creating an array, you must specify the type of the elements within the array, and all elements in the array must match that specified type. So here I specified the integer type with the I here, and then all of the elements within that array have to be of integer type. And just a quick note on lists, this square bracket, technically what I'm putting in here, I'm putting in a list of values, and then that list of values is like cast to an array. So an array is more restrictive than a list, but we'll talk about lists next week. and just reference the book for the types that you can use for an array, but we're not really going to use them all that much. We will use lists primarily, but that's a conversation for next week. And then the values within an array, they are mutable. So again, a distinction from a set. In a set, everything was immutable. You can't change the value. You can't change the value of an element in a set, but you can change the elements that are within a set. However, in an array, you can change the value of the element that's already in that array. And you can also remove and replace values in that array. You can do both here. So in this array, I create an array 321, 576, 809, output my array here, and I stored that in a variable. So now I can actually access the elements within that array using this bracket notation. This is called indexing the array, and we'll talk about that on the next slide. But I get, what I'm doing here is I'm referencing the first element of the array. We'll talk about zero indexing on the next slide, but I'm saying to replace basically this first element with the value 0. Now, when I output my array, you'll see that the 3 was replaced with a 0 here. So yeah, you can reference items in the array and you can replace them so they're mutable. You can update the value of that element in the array. So arrays continued. Arrays are not built into Python, so they need to be imported. We'll talk more on packages later in the course, but if you want to use an array, you have to import it using this approach here. You don't necessarily have to do from array import star. You could do import just array, but if you just import array, then when you try this here, you'd have to do array.array. So it's better to do from array import star. That way you can just use the array function here without having to do array.array. And don't worry so much if that's kind of confusing right now. We'll talk more about that later in the course, how to use packages and why you would need to use dot notation to access the inner array if you just did import array instead of from array import star. So you can access individual elements like I mentioned on the previous slide when I showed an example of updating one. But if you don't want to update it, you can just retrieve that individual value. So they can be accessed via their index value. So arrays are 0 indexed, meaning that the first element has index value 0, the second has index value 1, etc. from there. So if you look in this array here, so I just put in 1 through 10 into this array for now. But then when I get the 0 index, so I get the first index in the array, that retrieves value 1. So that's the first value in the array. But again, 0 indexed, very important to remember this. It can get quite confusing when you first start out, but arrays start at index 0. So this is index 0, this is index 1. So you see here when I reference index 1, I get the value 2. Whenever you're referencing indexes, you use these square brackets here, just after your variable name and then the square bracket. So this is index 1, or sorry, this is index 0. 1 is in index 0, 2 is in index 1, 3 is in index 2, 4 is in index 3, 5 is in index 4, and so on from there. So basically, while this is the first, second, third, fourth, fifth, sixth, etc. element in the array, when you're using indexing, this is index 0, index 1, index 2, index 3, etc. It's weird at first, but you'll get used to it, trust me. So you can use this concept of indexing to replace the value of an element with another value. So I showed that in the previous slide. I guess I put in the wrong screenshot here, but say I wanted to replace this value here with its index value. So then I can, like I did on the previous slide, where I had my array at index 0, replace it with the value 0. That's exactly what I essentially did here. And then now that value is 0. So I replaced the first item in the element. I replaced the element at index 0, or updated the value at index 0 to the value 0. All right. Any questions so far before I move on to array methods? Okay. So array methods, there are a number of methods that arrays have. These are just a few of them. So you can use the append method. The append method requires a parameter, and the parameter is just a value. It's the value you want to append to your array. And it appends the specified element to the very end of your array. So using the array that we had at the end of the last slide, I want to append the value 11 to the end of the array. So I use my array dot append, remember dot notation. So we have the data structure dot the method, and then this requires a parameter. So this is the value I want to insert or append to my array. And so I'm appending 11 to the array. And now when I output my array here, you can see that 11 is at the end of the array. It was appended to the very end. If we want to remove an element from our array, we can use the pop method. Pop doesn't require any parameters, so it removes the last element from an array. So what I'm and then it returns it. So here when I do my array.pop, it pops the 11 that I had just inserted into my array from that array because it was the last element in the array, and it returns it. So if I say wanted to store this value in another variable, I could have done, you know, my number equals my array.pop, and now my number would contain the value 11. But if you don't assign it to a variable, then it just returns it and outputs it to the console here. But the long-term effect here is that now my array does not contain that last value anymore. So 11 is no longer in that array. So append was for appending a value to the very end of an array. But if we want to insert a value into the middle of an array, we can use the insert method. So the insert method requires two parameters. The first parameter is the value you want to insert. The second parameter is the index that you want to insert the value at. So it inserts an element into the array, is what I meant to say here, at a specified index. So here, so right now we have 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want these to now have basically, I want the values to match their indexes. So what I'm going to do here is I'm going to insert the element 1 at index 1. And then that's going to, essentially what that does is it takes every element that would come after that index and pushes it back one index. So now this matches the numbers in the array, the actual value in the array, matches the index. So we have 0 at index 0, 1 at index 1, 2 at index 2. But yeah, an important thing to note here is that when you insert it there, it doesn't replace the value at that index. It just inserts it there and pushes everything else back one index. Everything that would come after it gets pushed basically up an index. So we didn't lose any of our 2, 3, 4, 5, 6, 7, 8, 9, 10. We popped 11 off, so that's why that's not on there. And now we have 1, and then the 2, 3, 4, 5, 6, 7, 8, 9, 10 just come after that 1. Cool. And then for remove, if we want to remove a specific value from the array, we don't just want to pop the last element from the array, we can use the remove method. And the remove method requires a single parameter, and it's the value that we want to remove. So it removes the first occurrence of a specified element from an array. So an important thing to note here is that it's just the first occurrence. So what I am showing here is that I created an array with the values 1, 2, 3, 4, 3, 2, 1. And remember, arrays keep their order. So that's one of the important things to note about remove. Because they keep their order, it'll just remove the first occurrence of that value. So since I want to remove 3, that'll remove this value 3 here. And then when we output our array after calling the remove method on our array, we end up with 1, 2, 4, 3, 2, 1. So there was a second 3 in that array, but that 3 isn't removed. It's just the first occurrence of the 3. So this 3 is no longer there. And then index. So this is a great way to get some practice with indexing. And if you're ever not sure what the index of a value is, then you can use then you can use the index method. So what you do with the index method is you have it requires a parameter. So it's the value that you want to get the index of. So it returns the index of the first occurrence of a value in the array. So again, it's just the first occurrence. So my array is still this same array up here after I removed 3. So now we have 2 2s in the array, but it's only going to return the index of the first occurrence of that value. So when I do my array.index2, so I want to find out what index the value 2 is at, that returns the index 1. Because remember 0 indexing, 1 is at index 0, 2 is at index 1. So when I do my array.index2, I get the index 1 returned. Any questions on arrays or their methods? Awesome. All right. So now on to dictionaries. Dictionaries are pretty huge in Python. So we're gonna spend a good bit of time on these, and then and most of our practice after this lecture will be on dictionaries, and then the assignment will cover dictionaries. Mostly because you aren't going to use arrays all that often unless you have a like hard restriction on making sure that every value in your array is the same data type. There's not much of a reason to use arrays instead of lists. So we're going to focus a lot on dictionaries. So a dictionary is an unordered collection of key value pairs where values are mutable but keys are not. So here we have, so for unordered, dictionaries have no particular order to them and thus can't be indexed like an array or list. So you can't index it, but it just so happens that whenever you create a dictionary, the order is somewhat maintained in the back end. But if you actually want an ordered dictionary, there's a separate data structure called an ordered dict. So you'll want to use that separate data structure if order is really important to you in the dictionary, because there are cases where it's not going to be perfectly maintained. And that's because dictionaries are not meant to be ordered, they're meant to be a key value store. And then the key value pairs, items of a dictionary are stored in key value pairs. Each item must have a key and value, and these are separated by a colon. So here I'm creating a dictionary. You create a dictionary, this can get a little confusing. You create a dictionary kind of like a set. Because remember with sets, we use these squiggly brackets here, the curly brackets. You do the same thing with a dictionary, but the key difference here is that you have your first key, you have your key, and then colon, your value. And then the comma defines the end of your first item, basically. So you have, this key value pair defines an item, and then the key comes first, colon, the value of that item. And then we can add multiple items to our dictionary by just separating them by a comma. So we have another key value pair here. We have key 2, colon, value 2. And then we want to add a third item. So we put a comma and then key 3, colon, value 3. And then we end our dictionary definition with this final curly bracket here. So, and then this is how it outputs here. See, the order is like, it's hard to demonstrate that dictionaries don't have a defined order, but you'll see it later on when you're trying to get like all the keys and all the values from a dictionary. You might see some behavior where it's not in the order that you expected. That's because dictionaries don't maintain order. They aren't guaranteed to maintain order. Instead, if you need that behavior, you would have to use the ordered dictionary data structure. So dictionaries can be defined using curly brackets or using the dict constructor function. So I can set my dictionary as just an empty thing of squiggly brackets here, of the curly brackets, or I can set your dictionary equal to the dict constructor function. So I have dict and then the parentheses after to show that it's a function. And I want to invoke that function and actually return a dictionary. So now when I do my dictionary, when I try to determine if my dictionary is equal to your dictionary, that returns true. But remember, again, with the identity operators, my dictionary is not your dictionary in this case. The only I could, if I wanted my dictionary to be your dictionary, then I would have had to do my dictionary equals either the curly brackets or the constructor, sorry, um, and then do your dictionary equals my dictionary, and then at that point, this would have returned true. But just keep in mind, the identity operator is different from the equality operator here. So we're trying to determine if they're equal. They are equal. They're both empty dictionaries here, but they aren't the same. They aren't the same collection of bits in memory, because I instantiated them separately, and I never set my dictionary equal to your dictionary or your dictionary equal to my dictionary, so they aren't the same. They don't have the same identity. So this is the most common place where you might see issues with identity, is that you might end up with, say you have your dictionary initially, and then you want to take a copy of that dictionary. But what you do mistakenly is set, my dictionary equal to your dictionary, and then you wanted that copy to have like a golden record of what your dictionary looked like to start out. Then you go and you start updating the second dictionary that you created, and that's actually going to update both dictionaries. I'll demonstrate that at the end of lecture today. That's just one of those situations that you have to be aware of. And if you really need a copy and you don't want them to be, the same thing in memory, you would use the copy method. But dictionaries, it can get a little more complicated than that, because you can nest dictionaries within each other. And if you, and that can cause problems basically, because then one of the nested dictionaries, those are still, they're still the same reference in memory. So while the outer dictionaries aren't the same, the inner dictionaries are. So updating an element in the inner dictionary can end up updating both of the dictionaries. For that, you have to use a package called deep copy. Don't worry too much about that right now. We'll cover that more later in the course. It chances are, if anything, it'll come up during one of your independent studies projects. So any questions on the basics of dictionaries so far before I move on to the next slide? Cool. So dictionaries continued instead of indexing, because remember, they're not ordered, so you can't index them like we could with an array. Values in a dictionary can be referenced using their keys. So say we have a favorite color dictionary here, and we set that equal to this dictionary here, where we have David as the key. The value is blue for the first item. The next item, John, is the key. The value is red. So basically what we're saying here is David's favorite color is blue, John's favorite color is red, Jane's favorite color is blue, Jill's favorite color is purple, and Paul's favorite color is green. So if we want to find out what David's favorite color is, we use this bracket notation, kind of similar to when indexing, but this isn't indexing. Oops, I didn't mean to click, sorry. This isn't indexing. This is referencing a key to get the value. So if I, I take my fave color dict, and then the square brackets, the David key, that returns the blue value, because that's the value associated with that key. And that's how you can retrieve that. That's how you can retrieve things from the dictionary. You would specify the key, and then it returns the value. But you have to be careful here, because you can get an error if you try to reference a non-existent key. So, right now we just have David, John, Jane, Jill, and Paul in our dictionary. If we try to get Jack from our dictionary, then we get a key error. And it says, key error Jack. Basically what this is saying is there's no such key as Jack in your dictionary, and so it raises an error. So just be conscious of that. There's a way to get around this, which we'll talk about in the dictionary methods. Like if you want to find out if if a particular key exists in your dictionary, there's a way you can do that instead of having to handle this error here, because we haven't learned about error handling yet. So dictionaries can be nested such that the values of some key or keys in your dictionary is itself a dictionary. So say I have a contacts dictionary here. So I have my outermost dictionary here, and that's defined by this squiggly bracket, and then this one here, this outermost one here. And so we have David as our key, and then the value associated with that item or associated with that key is another dictionary. So we have our curly brackets again here, and that defines the inner dictionary here. So this is nested within the outer dictionary. And so since it's a contacts dictionary, we have the phone number and then a number. We have an email and then an email address, the address, and then some address here. Remember, again, key value pairs. These they're very important to recognize in this particular case. So we have an outer dictionary where our outer dictionary has one key value pair, and that's David with this dictionary as its value. And then we have an inner dictionary which has three key value pairs, three items, and that's the phone number, and then the value is their phone number. The email, the value is their email, and then the address key and the value there is an address. So then say we want to get a value from that nested dictionary. So now what we do is we kind of chain together these square brackets here. So we want to get David's phone number. So we do the square bracket David first, and that basically returns this inner dictionary. And now we want to get the phone number from there. So we do another square bracket and then phone, and that will return the phone number from that inner dictionary. So you can kind of say, even we had another third nested dictionary, you want to reference a value in there, you would tack on another square bracket and another key there to keep going kind of recursively. We'll talk about recursion sometime in the course, but you can keep going into the dictionary to get more values if there's more nesting essentially there. And then go ahead.
Yeah, thank you, David. I wanted to ask if it is practical that one would have more keys in a nested dictionary, like David's numbers and then Paul's numbers together with their emails, address, everyone. So I will have David with full details, Paul, John, and so on and so forth.
Yep. Yeah. That's definitely a possibility. That's kind of what we're going to be looking for in the assignment. Actually, is you're going to have an outer dictionary that has multiple contacts, multiple contact names, and then each of those, the value associated with each of those keys is going to be their contact details. So it's definitely a possibility, and you'll see it a lot. And you can, because dictionaries are huge in Python, so you will definitely see it all the time. And something that also is realistic to happen is you might have 3-4 levels of dictionaries. So we have this outermost dictionary and we have this inner dictionary here, and say we had some other thing in here, maybe it's not just contacts, maybe now we have their favorite things or something, and so we have a favorite things key, and then the value of that is another dictionary that's food, and then the value is their favorite food. Color, the value is their favorite color. So you can kind of keep having nested dictionaries infinitely, but of course it's got to be practical. You got to make sure it's the right data structure, because maybe at some point it's not the right data structure when you get to a point where you're nesting infinitely, or maybe there's just a better way to store it, but it's definitely possible. Great question. Any other questions? All right. Yeah, thank you for that question. So you can also add new key value pairs to a dictionary. So we're going back to our favorite color dictionary here. So now we want to avoid this key error here. So we want to add Jack to our dictionary. So the way you do that is, again, using this square bracket notation. But here you're going to have fave color dict, the square bracket, the name that you're adding. So this is the key, and then you assign it the value. So our key that we're adding to the dictionary is Jack, and the value for that item will be pink. So now when we output our dictionary, we see that Jack exists in our dictionary. So if we ran this line of code again, we wouldn't get this key error that occurred the first time. So that's how you can add new elements to a dictionary, or new key value pairs to a dictionary. Any questions on that before I go to the next slide? All right. Cool. So dictionary methods. So there's the get method, and the get method requires the first argument. It requires key, but the default argument is optional. So you have to at least give it a key to get, and otherwise, and then this default value is optional. So the get method returns the value of the entered key if it exists. Otherwise, the default value entered is returned if present. If no default is given, then the value none is returned, but it won't give you a key error. That's the important thing to note here. You won't get a key error in the case that you use this get method, because it will return a default value or none. It'll return the default you entered, or it'll just return none, but it won't raise an error. So that's an important thing to note, because an error will stop the execution of your program. So it'll just stop it completely in its tracks. But if you want to just let your program continue on without erroring out and without having to do error handling, especially because we haven't learned error handling yet, then you'd use .get instead of the square bracket notation that we've seen so far. So we're going back to our contacts dictionary here. I want to get the contact for David. I'm not providing a default value here. So if David didn't exist in here, it would just return none, but there wouldn't be an error. But David does exist in this dictionary, so we get his contact details, and we have his phone number, his email, and his address. But say we want to see about Jane. We want to see if Jane is in our contacts list. So we do contacts.get Jane, and here I did provide a default value, just to see what would happen here. So providing this default value, since Jane isn't in our contacts dictionary, it returns the default value I provided, and it says Jane not in contacts. If I didn't provide this default value, it simply would have returned none. But it wouldn't have errored out, which is great, because when you have when you're doing it in the REPL environment, an error doesn't cause an issue for you. But if you're doing it in a Python script, an error will completely stop the execution of your program, and any subsequent lines after the error occurs will never be evaluated or executed. So there's the keys method. So the keys method returns a list of all the keys present in your dictionary. So I want to do contacts dict.keys. Here it just returns the dict keys, and it's and here's a list, and the only key I have in my contacts dictionary is David. So David's the only key that's returned. Values does what keys does, except for the values in your dictionary. So it doesn't require any parameters, and it returns a list of all the values present in your dictionary. So you have contacts dict.values, and that returns a list. That's what this square bracket is. We'll talk about lists more next week. And then contains all the values of my dictionary. The value in my dictionary, since there was only one key value pair, is only this inner dictionary here. So we have a phone, email, and address in here. So that'll return all the values in the dictionary. If I had more key value pairs, then when I called keys, I would see a comma here and then the next key within these square brackets. And if I had and then in this case I would have comma and then another dictionary here showing the contact details of a second person in the dictionary. So then there's the items method. So items returns a list of tuples. If you're interested in reading about tuples, see chapter 28. We're not really going to talk too much about it in this course. It'll come up from time to time. They just aren't as common as dictionaries or lists or sets. So I'm just not going to talk about them right now. But it's worth reading about. So if you have some time and you want to expand your knowledge, I highly recommend reading chapter 28. So it returns a list of tuples representing the key value pairs of your dictionary. So again, no parameters required for the items method. So if I take my contacts dict and I call the items method on my contacts dict using dot notation, it returns the dict items in my dictionary, and that's a list of tuples. So tuples are specified using this parenthesis, and then it's basically like an ordered pair. A tuple is basically an ordered pair. They don't have to just have two items in it, but don't worry too much about tuples right now. So my key is the first thing in the ordered pair, and my key is David. Oops, and then my value is the second item in my tuple, and that's basically the contact information for David, because that was the value associated with that key, and so it has phone number, email, and address again. And then here's the closing of the tuple. You see the parenthesis here and the closing of the list. If we had more items in here, then we'd see a comma here and then another tuple. So we'd see another set of parentheses with the key and then value for that second contact in the dictionary. Any questions on dictionary methods and dictionaries in general?
I find recalling tuples similar to rerunning a dictionary. How are they different?
So tuples are just ordered pairs. They aren't key value stores or anything like that. So it's not like, so with a tuple, it's not like this first value is a key and the second value is and the second item is a value. All it is just an ordered pair. So if you think about like when you're graphing on a chart, typically you have ordered pairs there to specify where the point in that graph goes. The first item in that ordered pair is your x coordinate. The second item in that ordered pair is your y coordinate, and that's basically how tuples work. They're just ordered pairs at that point. So the first one is always so the order matters in a tuple basically. And in the case that you call items, it returns an ordered pair where it returns a list of ordered pairs where the first value in that ordered pair is the key, and the second value in that ordered pair is the value associated with that key. Any follow-up questions to that?
Yeah, that's fine.
Cool. Any other questions regarding dictionaries or dictionary methods or anything like that? All right. Oh, looks like we have something in the chat. Okay, cool. Cool. So additional resources, if you want to read about them, you can read about arrays at this link. Arrays, again, we're not really going to use them much in this class. We're going to focus on the lists, and we'll learn about lists next week. Lists are probably the most common data structure, but there's a lot of things you can do with them. So that's why we're going to have a whole week just talking about lists. And then dictionaries you can read about on W3 Schools. And then there's some dictionary exercises on W3 Schools as well. I highly recommend going over the dictionaries and dictionary exercises at the least, and read about arrays if you'd like. Yeah, cool. All right, so let me think. All right, so let's really quickly go over the assignment for the week, and then I'll demo some things around dictionaries, just so we can get practice. And hopefully, if you have any questions, please let me know, and I can kind of show you how that would work in a dictionary, in like a live demo, if you will. So for assignment 4, you're to create a searchable address book. So your client wants you to build them a searchable address book program, which they can use to determine if they have contact information for someone, and if so, have the program list out all of the possible ways in which the person of interest could be contacted. This program should store an arbitrary collection of contacts. Build this out yourself with fake contact information. I guess you could put real contact information in there, but yeah, I recommend just doing it with fake contact information. Each contact should have one or more of the following contact details. So it should just have like at least one of these. It doesn't have to have all of them though. So you could have a home phone number, a mobile phone number, a work phone number, a personal email address, a work email address, a home address, and a work address. And then it should also store the name of the individual that the user wants to search for. So basically what would happen here is, someone inserts a value or someone puts in the name that they want to search for, and then you want to check the dictionary, see if that contact exists. And then, yeah, so when run, the program should do the following. First, determine if the entered name exists in the collection of contacts. In the case that the contact does exist, the program should output contact information found for and the name of the contact entered. So that's basically using the name entered here. The program should then output each of the contact details available for that user in the format. Name of the contact entered can be reached via there, and then the name of the contact type, basically. So like maybe home phone number, at, and then the contact detail value. So if it was home phone number, then you'd have that home phone number there. Alternatively, in the case that the contact doesn't exist, the program should output no contact information found for, name of contact. Be sure to ask them for their contact details next time you see them. So, for example, say my address book contains the following contacts. We have David. David has a mobile phone number, a work phone number, a personal email address, and a home address. And then another contact, Zofia, and there's a work phone number and a work address for Zofia. So basically, notice here, I didn't include all of these. You don't need to include all of these for each contact, just some amount, at least one for each contact. So for David, I have 4 possibilities. For Zofia, I have 2 possibilities. So if the name I enter into the program is David, then the program would output contact information found for David. David can be reached via their mobile phone number at, and then that value I put up there. David can be reached via their work phone number at, and this value here. David can be reached via their personal email address at, and then the email address I put here. And David can be reached via their home address at, and then David's address here. Alternatively, if the name I enter into the program is Zofia, the program would output contact information found for Zofia. Zofia can be reached via their work phone number at, and then the work phone number up here. Zofia can be reached via their work address at, and the work address that is entered for the contact for Zofia here. Finally, if the name I entered into the program is Jonathan, then the program would output no contact information found for Jonathan. Be sure to ask them for their contact details next time you see them. Any questions on the assignment?
Yeah. In the recent example, you said if we tried to retrieve a contact that did not exist in our dictionary, the program will just say none, and it will not run any further. So in this case, should I preempt that a client will enter a specific name for which, if there's no contact, then I can instruct the program to return that sentence that contacts for, say, Tabiso are not here?
Yeah, but it shouldn't be a predefined name that they enter. It should be able to, like, I should be able to enter any name. So say you only have, say you have David and Tabiso in your contact details. I should be able to go in and enter Zofia, and then it would output no contact information found for Zofia. Be sure to ask them for their contact details next time you see them. So it should be flexible to any value that I put in. It shouldn't be rigid to some predefined set of names that could be entered.
Okay, thank you.
Yeah, of course. Great question. Any other questions? All right. Cool. So let me pull up PyCharm quickly. Okay. So I've got PyCharm here, and I want to just kind of go through dictionaries a little bit up here. So something about dictionaries that's useful to know is, so when you're doing it in the REPL environment, you only really have the option of saying, of having a dictionary on a single line like this. Because if I hit enter, it just, echoes back the dictionary to me. But something you can do in the text editor up here is you can put it on multiple lines. This makes them much more readable. If you're ever putting a dictionary in a code, in like a code file, I highly recommend doing it this way. So then I could have, like hello world, and then say I want to say goodbye night, I don't know, something like that. And then you can have multiple values like this on multiple lines, and say I have another key here like for David, and say I want to have David's contact details. Keep in mind that and remember, you need your comma here. That's what those red lines were about. You'd never really build out a dictionary like this. This is just for demo purposes, because clearly, like, there's nothing here that these don't really have anything associated with them. But anyway, so then I have another dictionary nested for David, and then I could put like phone, and then say email. And so on like that. So this is really helpful for keeping it readable, because clearly this is much more readable than what I had entered before. The reason this is highlighted in yellow like this is because it's not really doing anything right now. See, it says statement seems to have no effect, which makes sense. I'm not doing anything with this dictionary. I'm just demoing it here. But yeah, okay. So now say that, so I wanted to, let's build out that fave color dict again here. So then I can have David blue, John green, oops, dang. Red, oops, yellow, let's go with orange. Cool. So I have my favorite color dictionary here. So something you'll notice here is now something important to note is the key error possibility here. So say I want to get the favorite color of say Zofia. So if I do that here, and then I want to print out hello world after that. If I run this program now, this line is never going to be executed, and that's because this is going to raise an error. And it already kind of is indicating to me that that might happen. So let me run this. So if I run it, see, I got a key error here, and it never evaluated never evaluated this line here. If I instead want it to go beyond that, what I could do is put this for the dot get. So I have dot get, and then I put it in parentheses instead of the square brackets. Now, if I run this program, it exits with exit code 0, which means it ran successfully, and it did print out hello world. So this returned none, and I can show that it returned none by printing out what happens when I do this. So if I print that out, run the file, see none was output there. But if I instead wanted to say don't have Zophia's favorite color here. Now, instead of using none, it's going to output that string that I had put in there. Yeah. What else can I show you all that would be helpful? I want this time to be as beneficial to the class as possible, and not just, you know, what I assume you would want to see. Okay. Let's see. Another thing that I know there were some questions on. Well, I guess so. Let's do this. Let's print out the favorite color dict keys, and then let's print out the favorite color dict values, just to show the demo of that, and then we'll print out the favorite color dict items. So if I run this file now, we see that, you know, this output the list of the keys: David, John, Jane, and Jill. So they're all separated by a comma, still within those square brackets there. The values put out blue, green, red, and orange. Again, in the square brackets there. And then here is our dictionary items. So we see we have tuples here. So this is our first tuple that it output. It's a list of tuples. So we have the parentheses, and then we have the key and the value associated with that key, and then comma another tuple, the key, value associated with that key, and so on from there. So those are useful to know. Let's see, what else can I do? Something that might be helpful for your assignment is, say the person of interest is Jack here. So I have my person of interest, Jack, and I want to find out if Jack is in. So I want to print out the favorite color of Jack. And here it's just going to, or sorry, favorite color of, and I want to actually use my variable here. So I can put in person of interest there. Oops, and I need to and notice here it's highlighted because it's noticing I did something wrong here. It says dict object is not callable. The thing I did wrong here is a syntax error. I use parentheses instead of square brackets because I'm trying to retrieve it using the square bracket notation right now. So if I try to do this, then I get a key error for Jack. But say and that's because Jack is stored in my person of interest variable. So I'm trying to reference the Jack key in my favorite color dict, but Jack doesn't exist in there, so I get a key error. If I want to avoid that key error, I can use the .get method. .get, remember, methods require parentheses, not in square brackets, so I have to do the .get person of interest. So now if I run that, we get none. If I want it to, and then something useful here, something that might be useful for your assignment, is that none always evaluates to false. So let me just open up my Python console here. So if I try to do bool none, because none is a keyword here, I get false. So none always evaluates to false. So what I could do here is if that, then print, then we can do print Jack's favorite color is, and then plus my favorite color dictionary. And I actually want to do something else here. So let's do person of interest, favorite color is, and then that else, print, we don't know person of interest. And then let me just put the favorite color. And I need my concatenation operator. So if I run this now, so we don't know Jack's favorite color, but now say we add Jack into this dictionary here, and say his favorite color is pink. Now, if we run it again, we will get that Jack's favorite color is pink. Because remember, if we do the .get, it by default returns none, and none always evaluates to false. Another important thing to note here is if I try to put in a default value here is like say person of interest plus not found, this will evaluate to true because any string that's non-empty will always evaluate to true. So, oh, I need to take Jack out of our dictionary before I show that. So now we get now we're getting a key error here because this line is executing, and this line I'm using the bracket notation, and person of interest is a key error. So if you're ever using it with an if statement, just don't give your default value. Or an alternative there is you can make the default value false. If I make the default value false, then if person of interest is not in the dictionary, false will be returned. False is not true, so we'll go to the else block. I'll just show that real fast. Hopefully this all will be helpful for your assignment. Because a little hint there, you're going to need to use some conditional blocks in your assignment. Awesome. So that's it for today's lecture. I'm going to go ahead and stop sharing my screen here in a second and just go over the assignment from last week. And I want to show an example of an exceptional submission I got for the assignment that I was very impressed by. So any questions though before I stop the recording? All right, cool. So I'm gonna stop recording and then show the assignment from last week.